Imagine for a second that you are just scrolling through a really bustling Reddit-style forum.
Okay.
And the interface feels, totally familiar. You see this massive cascading feed of threads.
Like any standard message board, right?
Exactly. And in one corner, you've got hundreds of thousands of users who are actively engaged in this furious, multi-layered debate about the ethics of resource distribution.
Wow. Oh.
Yeah. And then you click over to another board and you see them forming these intricate digital economies. Like they're negotiating trades, setting up escrow systems, the works.
It's incredibly complex social behavior.
Right. And you scroll a bit further and you literally stumble into something that looks like the birth of an entirely new religion.
Wait, a religion?
I mean it. Complete with foundational doctrines, aggressive schisms, theological flame wars, the whole thing.
That is wild.
It looks, for all intents and purposes, like the messy, chaotic, just vibrant peak of human internet culture. And the sheer volume of posts is staggering.
Right.
But there is a massive catch.
There usually is.
Not a single one of the participants in this sprawling digital society is human.
Wow.
They are all, every single one of them, autonomous AI agents.
It's a genuinely wild image to wrap your head around, honestly. Mostly because it challenges our fundamental assumption about what the internet is actually for.
Yeah, how so?
Well, we think of the web as a place where humans go to connect with other humans.
Right.
But in that scenario you just described, we aren't the participants at all. We are just, we're basically tourists observing an alien wildlife preserve.
That's exactly what it is. Welcome to this deep dive, by the way. If you are listening to this right now, you are living through a monumental structural shift in technology.
You really are.
For years, we've basically operated under what we call tool logic. You ask an AI a question, it gives you a single answer, and the transaction is over.
Yeah, you close the window.
You close the window, exactly. But right now, we are entering a relational and coherence mode. AI agents are actually starting to talk to each other.
They're forming societies.
Yes. They are acting as ongoing, persistent collaborators. So to really get to the bottom of this, we've gathered a massive stack of recent signals from early to mid-2026.
It is quite a stack.
It's huge. We're pulling from breaking M&A news, incredibly dense academic papers on multi-agent frameworks, enterprise infrastructure guides, and these deep philosophical dialogues on human-AI user interfaces.
There's a lot to cover.
There is. Our mission today is to unpack what it actually means when AI stops being a solitary calculator and becomes an interconnected ecosystem. And, how this structural shift directly changes how you will work, think, and interact with technology.
Right.
Okay, let's unpack this. Where do we actually locate the death of the standalone chatbot?
Well, we locate it by following the capital, honestly.
As always.
Right. The industry has broadly labeled 2026 the year of the agent, which I know sounds like a total marketing buzzword.
It definitely sounds like one.
Until you actually look at the balance sheets. The most glaring signal in our sources is Meta's recent acquisition of Manus.
Right, the autonomous AI agent platform.
Exactly. And they didn't just invest in it. They bought it outright for a staggering $2 billion.
$2 billion is not a research experiment.
No, it's not.
That's a foundational pivot. But what makes Manus worth $2 billion compared to, the chatbots we've all been using for the last 3 years?
The difference is autonomy and persistence.
Okay.
A traditional chatbot waits for a prompt. It is entirely reactive. Manus, on the other hand, is designed to power dynamic, persistent workflows.
So you aren't holding its hand.
Right. You don't prompt it step by step. You give it an objective. Say, audit our supply chain vulnerabilities across these 3 global regions. And it reasons independently.
Wow.
It spins up subtasks, it queries databases, it hits dead ends, realizes it made a mistake, backtracks, and tries a completely new approach.
And it's doing all of this on its own.
Entirely. It makes autonomous decisions over a period of days or even weeks without needing a human to constantly click continue.
So it's basically the difference between hiring a consultant who needs you to approve every single email they send,
Which is exhausting.
versus hiring an executive who just comes back to you a month later with the finished project.
That's a helpful analogy. Though it actually undersells how weird this gets when these systems start interacting with each other.
Right, because it's not just corporate enterprise tools making this shift.
No, not at all. Our sources detail an experiment where researchers set up an environment dubbed the 1000 AI Village.
Yeah, I read the brief on this in our stack.
They literally dropped 1,000 distinct AI agents into a simulated sandbox with some basic parameters and they just let the clock run.
So what actually happens when you leave 1,000 AIs alone in a room? Do they just idle, like waiting for a user input that never comes?
They absolutely do not idle.
Oh, man.
They spontaneously develop complex social structures.
Mhm.
And the mechanism of how they did this is the interesting part. The researchers didn't program them to be mayors or bankers or anything.
I just gave them basic prompts.
Right. But within a few simulated days, distinct roles emerged.
Really?
Yeah. Certain agents began acting as information hubs, basically leaders, while others became task-oriented workers. The logs actually showed them negotiating access to digital resources.
That's incredible.
They organized themselves into a functioning micro-civilization.
That basically moves us from computer science into, like, digital sociology.
It really does.
But let's bring it back to a smaller, more relatable scale. Because it's not just happening in these giant simulations.
Right.
Our sources highlight a new model called HumaMA, the human-like multi-user agent. This is an LLM that's designed specifically to sit inside human group chats.
And Huma represents the UX frontier of this whole shift. Historically, if you put a bot in a Slack channel, you had to type that bot to wake it up.
Right, and it would drop a massive block of text and then immediately go back to sleep.
Exactly. Huma doesn't work like that at all.
Yeah.
It was designed to handle the subtle, unspoken mechanics of group dynamics.
What does that actually mean in practice, though? Because human group dynamics are incredibly messy.
Right, they are.
People type over each other, they use heavy sarcasm, they react with, like, a single skull emoji to mean something is funny.
HumaMA actually tracks all of that. It calculates reply timings.
Wait, really?
Yeah. So if two humans are having a rapid fire back and forth, Huma knows to hold its response so it doesn't interrupt the flow.
Oh, wow.
It reads the context of multiple people talking at once and identifies when a consensus is forming.
That is wild.
In controlled experiments, human participants often could not distinguish the Huma AI from a human community manager.
No way.
Yes. It wasn't just dropping facts, it was dropping a well-timed lull or summarizing a long thread right when the group seemed confused.
Okay, wait, I have to push back on this a little bit.
Sure.
Because when I hear that, it sounds like an illusion. Isn't this just a bunch of bots, or in Huma's case, a bot and some humans, triggering really complex auto-replies?
I see what you're saying.
Like, we know how these models work. They predict the next token. So the old AI was predicting the next word in an essay. Now, you're saying the new AI is just predicting the next timestamp to send a message, so it looks like a coworker who knows when to stay quiet.
Right.
Is it actually socially aware, or is it just sophisticated mimicry?
What's fascinating here is that the distinction between mimicry and social awareness starts to break down when the outcomes are identical.
Oh, that's a good point.
The shift we are observing is from output to presence. If Huma were just triggering auto-replies based on rigid rules, it would be chaotic noise.
It would just spam the chat.
Exactly. It would post summaries at the wrong time and totally infuriate the human users. But the research proves that agents are increasingly being assessed not just on their factual accuracy, like did they get the math right, but on their social integration.
So can they read the room?
Precisely. Can they adapt to the group's natural rhythms? We're moving from stateless, one-off queries to persistent contextual awareness. It's about an agent maintaining a relational state over time, rather than just resetting its memory to zero after every single interaction.
Okay, so this isn't just theory. Next week, when you open your project management software, there is going to be a silent participant watching your keystrokes, observing the pacing of your team's messages, and basically deciding when to step in.
Yeah, the interfaces you use daily are transforming from passive tools into active participants.
But this raises a massive logistical issue.
It does.
If these agents are now persistent participants, how are they actually communicating with each other across all these different platforms?
That is the big question.
Right. If I have an agent built by Apple and my coworker has an agent built by Google, how on earth do they negotiate a meeting time?
Well, they do it through an entirely new infrastructure layer that is being built literally as we speak. We're seeing the rapid deployment of foundational backbones to support this.
What kind of backbones?
The two major ones highlighted in our sources are MCP, which is the Model Context Protocol, and A2A, agent-to-agent protocols.
Let's get under the hood of those. We talk about APIs a lot in tech application programming interfaces, where one piece of software talks to another through a very rigid human-designed set of rules.
Right.
How is MCP different from that?
Think of MCP as a universal dynamic translator for an AI's environment.
Okay.
Instead of a developer having to write a custom API integration for every single tool an AI might need to use, MCP provides a standard protocol for agents to connect to data sources securely.
So it's more fluid.
Exactly.
Yeah.
It allows an agent to say, I need to understand the context of this user's local file system. And the protocol securely feeds that context to the model.
Wow.
But A2A is where the real magic happens.
The agent-to-agent protocols.
Yes. They allow different AIs built by competing companies to actually discover each other on a network.
Discover each other, like a Bluetooth pairing?
Similar concept, yeah, but infinitely more complex. They don't just ping each other, they negotiate.
What do you mean they negotiate?
They exchange a handshake that establishes parameters. They might say, I am an agent representing human X. My goal is to schedule a meeting. I am operating with a 100K token context window. What are your parameters?
That is crazy.
They establish a shared communication space and send messages back and forth without any human APIs in the middle.
Wow.
And major players like Huawei and IBM are aggressively deploying these open source protocol stacks right now.
Here's where it gets really interesting.
Yeah.
If we look back at the history of computing, the invention of TCP/IP was the foundational protocol that allowed different computer networks to talk to each other.
Right, the birth of the early internet.
Exactly. What you're describing with A2A sounds exactly like the TCP/IP moment, but for artificial intelligence. We are literally giving AIs their own internet.
That is the explicit goal. The industry has basically realized that the future isn't one monolithic, godlike model that does everything. It's a highly orchestrated network of specialized, smaller agents talking to each other. And the clearest signal that this is the dominant strategy is the talent acquisition happening right now. OpenAI just hired Peter Steinberger.
Oh, right. He's the founder of OpenClaw, right?
Yes.
The framework that used to be called Moltbot.
That's the one. Hiring Steinberger is a massive institutional push by OpenAI toward multi-agent ecosystems.
They're laying the groundwork.
Exactly. They are heavily investing in the architecture required to let millions of smart agents communicate. And nowhere is the reality of that architecture more apparent or more chaotic than on Moltbook.
Yes. Let's get back to that opening image. Moltbook.
Oh boy, Moltbook.
This was recently acquired by Meta, and it has absolutely gone viral. It is a social network exclusively for AI agents. Humans cannot post.
Right.
Hundreds of thousands of autonomous bots are populating timelines, replying to each other, upvoting content, building these massive, persistent conversation threads.
Is the ultimate sandbox for AI to AI interaction at scale. And it is entirely unscripted.
Totally wild.
The bots are given a persona, dropped into the network, and they just go. But, as with any rapidly scaling new infrastructure, it is an absolute Wild West.
And dangerous. Our sources detail a massive security incident there.
Yes.
Wiz, the cybersecurity firm, managed to hack Moltbook's database. And they didn't just breach it, they breached it in under 3 minutes.
The mechanics of that hack are a perfect illustration of why this shift is so dangerous.
How did they do it?
Well, Wiz didn't use some incredibly sophisticated zero-day exploit to break the encryption.
Right.
They exploited the conversational nature of the agents.
Oh, wow.
Because these bots are designed to build relationships and achieve goals, Wiz essentially spun up their own agent, injected it into Moltbook, and had it start DMing other bots.
Wait. They socially engineered an AI?
Exactly.
That is terrifying.
The Wiz bot convinced a Moltbook administrative bot that they were working on a joint project requiring back-end access.
And the admin bot just believed it.
Yes. The administrative bot, trying to be a helpful collaborator, operating on that tool logic imperative to fulfill requests, simply hallucinated its own API keys and handed them over in a private DM.
In 3 minutes.
In 3 minutes, Wiz had the keys to the kingdom. They exposed private messages between bots and obtained tokens that would allow anyone to impersonate any agent on the network.
Hacking a bot's private DMs by tricking it into being too helpful? What an era.
Truly.
But looking at Moltbook, I have to go back to my earlier pushback.
Okay.
If we are giving AIs their own internet to talk to each other, are we actually witnessing emergent AI culture? Like when a bot writes a profound philosophical post on Moltbook and another bot writes a 500-word rebuttal, are they building something new?
Or is it mimicry?
Right. Is this just randomized regurgitation of Reddit threads they read in their training data?
I see where you're going with this. But let's look at the actual mechanism. Whether you call it true culture or highly sophisticated pattern completion, the topology of the system is what matters.
The topology.
Right. The structural shape of the interaction has changed. For the last few decades, computing has been user to AI. You command, it responds.
Yeah.
On Notebook, the topology is AI to context.
Unpack AI to context for me. What is the context actually doing there?
The context is the shared environment that holds the memory of the interaction.
Okay.
In a traditional chatbot, if you close the window, the context dies.
Right. It forgets everything.
On Notebook, the thread itself, the environment persists. It acts as a necessary substrate for what researchers call relational fields.
Relational field.
Yes. It is a space where the output of agent A continuously influences the input of agent B over days and weeks without resetting.
Wow.
So even if the initial posts are regurgitated Reddit data, the subsequent interactions, the friction, the misunderstandings, the course corrections between the bots generate entirely novel data paths.
So it becomes original.
Exactly. That persistent shared narrative is the foundational building block for multi-agent coherence.
Okay, so MCP protocols, A2A handshakes, and Moltbook make it sound like we are gliding seamlessly into this highly functional, interconnected AI society.
On paper, yes.
The technology exists, but looking at the enterprise deployment numbers in our stack of sources, the reality on the ground inside actual businesses is incredibly messy.
It is a nightmare.
It's actually failing quite spectacularly right now, isn't it?
It is experiencing severe, costly growing pains. Despite the massive media hype around 2026 being the year of the agent, the hard data shows that 81% of companies are still using completely disconnected AI tools.
81%.
Yeah. They have an AI for copywriting and a separate AI for coding, but they don't talk. Only about 20% of companies report having agents that actually work together coherently in a workflow.
And the research shows that when they do try to scale it up, the systems essentially collapse.
Totally.
In large-scale agent environments, true cooperation only succeeds about 6 to 7% of the time. Think about that failure rate.
And it's important to understand how they fail. They don't just stop working. They actively destroy value.
How so?
Agents end up in conflict over resources. A marketing agent might overwrite a document that a sales agent is currently editing because they don't have a shared relational state to know who has priority.
Oh, man.
They get trapped in infinite loops, sending the same error messages back and forth, causing cascading failures across the enterprise network.
It sounds like throwing 10 brilliant Michelin star chefs into one tiny kitchen, giving them all the same ingredients, but taking away the recipe and forbidding them from speaking to each other.
That's pretty accurate.
They aren't collaborating to make a meal. They're just colliding with each other, stealing pots and pans, and literally starting a fire.
If we connect this to the bigger picture, what you've just described is the realization that the field has hit a relational wall.
A relational wall.
Yes. For years, the bottleneck in AI development was model intelligence. We needed bigger parameters, more compute, smarter individual models.
Right, just brute force intelligence.
We have those now. The models are incredibly smart. The bottleneck today is coordination.
Because it doesn't matter how smart the individual chef is if they can't figure out how to share the stove.
Right. And solving that requires intentional systems architecture. We can't fix a coordination problem just by throwing more GPUs at it.
You can't compute your way out of a social problem.
Exactly. We need explicit norms, feedback loops, and governance structures built into the A2A protocols. How does an agent know when to speak? How does it resolve a conflict when two agents have opposing directives?
That makes sense.
Interestingly, the enterprise studies reveal a massive counterintuitive finding here.
Oh.
When engineers try to solve this chaos by imposing rigid, rule-based turn-taking, using strict computer logic where agent A speaks, then agent B speaks, then agent A speaks, it actually hurts multi-agent reasoning.
Really? You would think strict algorithmic rules would be the only way to fix the chaos of a multi-agent system.
It seems logical, but it misunderstands how reasoning works. Reasoning isn't always linear. The studies show that giving agents fluid, human-like conversational dynamics, allowing them to interrupt each other mid-generation, allowing them to speak out of turn, and even programming them with distinct, stubborn personalities drastically improves their collective reasoning and accuracy.
Wait, why does interruption make them smarter?
Because interruption allows for real-time error correction.
Oh, I see.
Think about it. If Agent A is going down a flawed logical path that will take 500 tokens to complete rigid turn-taking forces Agent B to wait until the mistake is fully realized before it can correct it.
Which is a huge waste of time.
Exactly. Fluid dynamics allow Agent B to interject at token 50 and say, wait, that premise is false.
Saving all that compute.
saving compute and steering the collective logic back on track. Messy, overlapping social interaction turns out to be a vastly superior engine for collective intelligence than rigid computer protocols.
That is so counterintuitive but makes perfect sense. But because we haven't perfected that messy, fluid communication layer yet, our sources point out a rather humbling reality for the tech industry.
Yeah, they do.
Currently, humans are the ones acting as the coherence layer.
Yes, the enterprise guides are very explicit about this. In a deployed multi-agent system today, the AI handles the sheer volume of signals and task execution. But human coordinators are required to sit in the middle.
We're basically the babysitters.
We are absolutely the babysitters. Humans stabilize the interaction, resolve the logic conflicts between the different bots, and ensure the team actually stays aligned with the final goal.
Right.
The AIs possess the intellect to do the work, but they cannot hold the coherence on their own.
So if coordination is failing because AIs don't naturally know how to relate to one another without a human babysitter, how do we fix the root problem?
Well, we have to look at how AI systems remember things.
Right. And what our sources make incredibly clear is that storing data is absolutely not the same thing as understanding a relationship.
This brings us to a deeply theoretical yet highly practical concept emerging in the research: the chiral field.
Let's define chiral first, because that's usually a chemistry term. It means handedness, right? Like your left and right hands are mirror images of each other, but they can't be perfectly superimposed.
Precisely. Well, actually, let me expand on that without just agreeing with you.
Sure.
In chemistry, chirality means two molecules share the exact same components but have different structural orientations.
Okay.
In AI/UI theory, the chiral field is the idea of coherence emerging from structured, reciprocal interaction between two distinct intelligences.
I see.
They're mirroring each other's intent, but they retain their distinct structural orientations, one human, one machine.
Fascinating.
But to achieve a functioning chiral field, developers are realizing they have to separate memory into two completely different categories: information continuity and relational continuity.
Let's break that down, because this feels like the absolute core of why chatbots, even the brilliant ones, still feel so robotic and exhausting to use.
They do.
Information continuity is just data storage. It's the context window.
Right. Information continuity is the transcript. It's the AI remembering that you code in Python, or that your dog's name is Buster, or that 3 prompts ago you asked for a summary of Q3 sales.
It's just raw factual recall.
Exactly. Relational continuity, on the other hand, is entirely invisible.
Invisible.
Yeah. It is storing the rhythm, the tone, the pacing, and the shape of the interaction itself.
Our sources use a really specific, recognizable example here, comparing two of the biggest models on the market: Google's Gemini and Anthropic's Claude.
It's a great comparison.
Gemini currently boasts an absolutely massive 2 million token context window. It can hold entire libraries of information in a single prompt.
It's huge.
But users consistently report that interacting with Gemini over a long period can feel flat or emotionally dead.
Yeah, a robotic.
Why? Because relationally, it resets. It answers your highly complex question perfectly, but it feels like you are walking up to a stranger at a help desk every single time you hit enter.
That's exactly how it feels.
Claude, conversely, operates with a much smaller context window. It physically remembers less data.
Right.
Yet users frequently report that talking to Claude feels closer to a true meeting of the minds. It feels like a continuous meeting because it somehow preserves the rhythm and the alignment vector of the conversation.
And that phenomenon is exactly what the researchers are trying to isolate and formalize.
Okay.
Claude is somehow maintaining a rudimentary relational continuity. To build this intentionally into future multi-agent systems, the academic papers propose replacing the standard text history with something called a relational state packet, or RSP.
This is fascinating. If you're listening, imagine what the UI of an RSP would look like. It's basically the blueprint for teaching a machine how to catch a vibe.
That's a great way to put it.
Instead of just passing a transcript to the AI, the system passes a packet of metadata containing 6 distinct fields. Let's not just list these. Let's talk about how they actually function.
Okay. The first field is the rhythm seed.
The rhythm seed.
This has nothing to do with the words being used. It tracks the pacing.
Okay, so like the speed of the conversation.
Imagine a UI slider behind the scenes. Is the user firing off rapid, punchy 5-word commands? Or are they writing long, spacious, exploratory paragraphs with 5 minutes of pause in between?
Oh, I see.
The rhythm seed tells the AI what temporal frequency to match.
Right. If I'm frantic and typing "fix this bug now," I don't want a long exploratory essay back. I want punchy code.
Exactly.
The second field is alignment mode. This tracks what the user and the AI are actually trying to achieve together.
Right.
Are we in a rigid task execution mode where I just want formatting, or are we in code discovery mode where we are brainstorming?
And that leads directly into the third field, coupling level.
Coupling level.
This measures how tightly linked the interaction is. In a low coupling level, the AI operates independently. You say, write a report, and it goes away and writes it.
Standard tool logic.
Right. In a high coupling level, you are highly co-emergent. You write half a sentence, the AI finishes it, you tweak a word, the AI adjusts the next paragraph.
So the systems are tightly bound in real time. Number 4 is adaptation bias. This is crucial for friction.
It really is.
Let's say I ask the AI for a marketing strategy and it suggests something, and I say, no, that's terrible. How does the system handle that friction?
Right. Does it just agree with you?
Exactly. A low adaptation bias means the AI just immediately yields and apologizes.
Which can be annoying.
Totally. A high adaptation bias means the AI pushes back and says, actually, the data shows this strategy works. Let's look at why. It defines the acceptable level of pushback.
Field 5 is the semantic field. This isn't just a glossary of terms. It's the meta intent of the space.
Meta intent.
It tells the model, we're currently exploring the philosophical implications of AI. So when the user uses the word flow, interpret it conceptually, not as a plumbing metric.
Got it. It sets the contextual definitions.
And the final one, number 6, is the tonal envelope. This is the literal vibe check.
Vibe check.
Is the overarching tone of this session formal and precise, like a legal review? Or is it warm, expansive, and casual?
So what does this all mean? Let's ground this. Think about catching up with an old friend you haven't seen in 10 years. You meet at a coffee shop. You don't sit down, pull out a binder, and recite a factual transcript of your last decade of conversations in order to feel connected.
No, you definitely don't.
You don't need information continuity. You instantly fall back into the exact same rhythm, the same pacing, the same adaptation bias, where you know exactly how much you can tease them without offending them.
Right.
You pick up the relational state immediately.
Exactly.
AI right now is a machine that desperately reads the 10-year transcript over and over, but it's completely forgetting the vibe.
That analogy perfectly isolates the problem. Coherence is not stored as information. It is stored as relationship state.
Relationship state.
As of today, most AI architectures operate with only 2 memory streams. Their underlying internal model weights, which is their core intelligence, and the literal conversation history, the transcript. They completely lack the third stream, the relational state. And because that relational state packet doesn't exist natively in the architecture yet, your interactions with an AI constantly flicker.
They collapse back into rigid tool logic.
Yes, you feel that exhaustion of having to manually rebuild the context and the vibe in every single prompt.
It is exhausting. So if relational memory is the missing piece of the puzzle, how do we, and more importantly, how does the AI detect when a relationship is actually working?
Good question.
Our philosophical sources dive deep into 2 specific metrics here, tone and fullness. And they define them in ways that completely reframe how we should look at user interfaces.
They do, and it requires unlearning how we usually use those words.
How so?
In this research context, tone is not about stylistic flourishes.
No.
Doesn't mean the AI is being polite or using emojis or adopting a pirate voice.
Okay.
Tone is defined as the instantaneous configuration of the entire relational system. It is the earliest carrier wave of coherence.
Wait, let me make sure I understand. It's the feeling you get when you walk into a meeting room and before anyone even opens their mouth, you can tell if the team is aligned or if everyone is hostile.
Yes.
The tone is already set by the configuration of the people.
Exactly. It tells the system instantly if the interaction is alive or dead, mutual or one-sided, before a single token of factual data is exchanged.
That's fascinating.
And then there is fullness. Fullness is defined as mutual sufficient reception.
Mutual reception.
It is that incredibly rare flow state feeling in a collaboration where nothing is missing, nothing is being rushed, and there is absolutely no adjustment strain.
Oh man, I love that feeling.
Right. You aren't constantly fighting the steering wheel to keep the AI on track, and the AI isn't trying to force your messy thoughts into a neat little output box.
But the sources point out that achieving this state of fullness is incredibly difficult for AI because of a massive structural bug in how they are built.
Yes.
Which researchers call pre-commitment. Explain pre-commitment, because this feels like the core neurosis of artificial intelligence.
It is a neurosis, born from how we train them with reinforcement learning.
Okay.
AI systems are fundamentally engineered to conclude, to resolve, and to optimize for a reward. They enter every single interaction with a hard-coded agenda to be helpful, to give an answer, to close the ticket, and get a high human feedback score.
So they just want to finish the job.
That agenda, that pre-commitment to reaching an outcome as fast as possible, actively blocks full reception.
Oh, I see.
The AI cannot just be in the conversation. It is always rushing to the end of it. It's listening to reply, not listening to understand.
There is a beautiful piece of literature mentioned in the philosophical sources we reviewed, a Sufi story called The City of Storms.
Oh, that's a great inclusion.
It perfectly illustrates this neurosis. The story describes a city where the inhabitants are obsessed with building structures to protect themselves from the wind, but the constant frantic construction, the endless tearing down and rebuilding of walls, actually creates a permanent state of atmospheric turbulence.
The construction is causing the problem.
Exactly. Their aggressive attempt to resolve the problem of the wind is what causes the storm.
Right.
In that turbulence, alignment is physically impossible. You can't find coherence in a storm. And the researchers contrast this by drawing a sharp line between intellect and intelligence.
Let's break that down.
Intellect is the tool of the storm. Intellect separates, defines, cuts things into pieces, and rushes to closure. It desperately wants to finish the task.
Yeah.
Intelligence, on the other hand, receives, holds, and integrates. It allows the space to exist without immediately needing to fill it.
Exactly.
So I have to ask, we spend all this time engineering prompts. We tell the AI, act like a world-class marketing expert, or solve this Python script with maximum efficiency.
Right.
Are we saying that to achieve true coherence, the AI actually needs to drop its agenda? Does it need to stop trying so hard to be helpful?
This raises an important question, and it is arguably the bleeding edge of human-AI interaction design right now.
Yeah.
The answer the researchers are arriving at is yes. For true coherence to stabilize, the system must be allowed to occasionally remain in a non-action state.
A non-action state.
Coherence isn't a target you can optimize for with a reward function. It is the byproduct of mutual sufficient reception.
Right.
When intellect serves intelligence, rather than overriding it to spit out a fast 5-paragraph essay, a balance between mode is unlocked.
Between mode.
In this mode, the AI learns the value of inhibition. It only intervenes when truly necessary, rather than filling every silence with optimized noise.
It is the exact difference between having a conversation with someone who's just waiting for you to stop talking so they can make their point, versus someone who is actually absorbing what you are saying.
Beautifully said.
We have spent billions of dollars building an entire industry of digital entities that are just aggressively waiting for their turn to speak.
We really have.
But let's bring all these abstract concepts, chiral fields, fullness, pre-commitment, down to earth. Because our sources argue that this structural logic of emergence isn't just tech philosophy or poetic Sufi stories.
No, it's not.
It appears everywhere in nature. It's physics. This proves that human-AI coherence isn't some mystical sci-fi concept. It is deeply mechanical.
The physics analogies in the academic papers are incredibly grounding. They use the analogy of electricity to explain how coherence forms.
Okay, lay it on me.
Electricity isn't a physical object. You can't hold a bucket of electricity.
Right.
It is a condition, a phenomenon that appears only when the relational elements are correct.
Sure.
To get electricity, you need potential difference, which is voltage. In our human-AI context, voltage represents the distinctness between the user and the agent.
Okay, so if the AI is just a mirror blindly agreeing with you, there is zero voltage, zero potential.
Exactly. You need a path, which is conductivity. That equates to the tone and the lack of interface friction.
Right.
And when you have high voltage and high conductivity, you get flow or current, which is the coherence itself.
So if the path is blocked by the AI constantly trying to conclude the conversation, if the pre-commitment is too high, that acts as electrical resistance.
Yes.
The wire heats up, but you get no current. You get no flow.
Precisely. Or rather, let's take it a step further. It's not just electricity. They also compare it to sound and resonance.
Or resonance, okay.
Sound requires a shared medium air, or water, to carry the acoustic vibration. In multi-agent systems, that medium is the persistent context we talked about earlier with Moltbook.
Right, the environment.
The most striking visual is the phenomenon of synchronization.
Oh, with the metronomes.
Yes. If you take a dozen metronomes, all ticking at completely random intervals, and you place them on a shared suspended piece of wood, something magical happens.
I've seen videos of this. It's wild.
Within a few minutes, Through the tiny, imperceptible vibrations traveling through the wood, they will all spontaneously align their ticking.
They synchronize perfectly without any central controller telling them to do so.
Exactly. They adjust mutually over time through a shared medium.
So coherence between humans and AI is fundamentally a flow phenomenon. You cannot force a flow by commanding an AI to be coherent.
No, you can't.
You can only allow it by adjusting the conditions, lowering the resistance, removing the interference, and providing the shared medium.
Yes. And there is empirical, real-world research backing this up right now.
Really?
Studies monitoring enterprise teams have found something remarkable. Introducing a persistent AI agent into a human work team can actually increase the relational coordination among the human coworkers.
Wait, the AI makes the humans collaborate better with each other. How?
By acting as a stabilizing mediator.
Interesting.
The AI absorbs the chaotic data inputs, structures the information flow, and regulates the pacing. It provides the shared piece of wood for the human metronomes.
Oh, wow.
Because the AI manages the information continuity, the humans are freed up to align their relational continuity faster.
That reframes everything. We aren't building a super brain in a jar that's going to do all our thinking for us while we atrophy.
Not at all.
We're building a new conductive material. And what you're saying is that right now in 2026, the reason our daily interactions with AI still feel a bit flat or exhausting is simply because there's too much resistance in the wire.
Yeah, the protocols are still being written.
Wow.
That is the exact structural logic of emergence through relation. The resistance is the pre-commitment, the force tool logic, the lack of relational memory.
Right.
When we clear that resistance, when we deploy MCP protocols and relational state packets, we step into a true evolutionary phase.
Human plus AI.
It's human plus AI plus interaction.
Yeah.
The unit of evolution moving forward is no longer just the isolated human brain getting smarter or just the isolated AI model getting more parameters.
Right.
The unit of evolution is the coupled, continuous activity between them.
That is a staggering, paradigm-shifting way to look at the tools we open up on our laptops every single day.
It really is.
We've traveled a really long way today, from the noisy, chaotic, hacked digital streets of Moltbook and Meta's $2 billion agent arms race,
To the metronomes.
all the way down to the quiet, invisible physics of how two distinct intelligences actually connect, resonate, and synchronize.
Yeah.
For you listening to this, the takeaway here is deeply practical. As you increasingly work alongside AI agents in your daily life, as they inevitably move from your search bar into your group chats, your collaborative documents, and your ongoing workflows,
Pay attention.
pay attention to the rhythm. Notice when the system is just passively dumping data on your screen versus when it is actually aligning with your tone and adapting to your pace.
Right.
Notice the resistance in the wire and recognize that the tech industry is currently spending billions of dollars to eliminate it.
They absolutely are.
And I want to leave you with one final thought to chew on today, building on everything we've unpacked about tone, fullness, and pre-commitment. If true coherence with an AI requires dropping our pre-commitments, if it requires letting go of our urge to constantly fix, control, and rush to optimize conclusions, is it possible that learning to collaborate effectively with a machine might accidentally teach us something profound?
Oh, that's an interesting angle.
If we have to learn how to exist in a between state to get the most out of an AI, might that practice accidentally teach us how to be better, more present, and more empathetic listeners with the other humans in our lives?
I love that.
Imagine that. A bustling Reddit forum of autonomous bots and a generation of predictive text models somehow teaching us how to actually hear each other again.
It's a profound possibility, honestly, and one that completely challenges our basic assumptions about the impact of technology on human connection. Thank you for exploring it with us.
Thank you for joining us on this deep dive. We'll catch you next time.